Alright guys, welcome to the Pre-algebra 10.5 video. We're talking about surface area and prisms, surface area of prisms and cylinders. So the first thing we're going to talk about is surface area. What is surface area? Well, it's the sum of the area of a solid's faces. Okay, so we're talking about solids. So that means three-dimensional objects. Alright, and the faces that they have. So for example, a pizza box has 1, 2, 3, 4, 5, 6 faces. Okay, technically it's a rectangular prism. All right, a soda can has, well, let's see, 3 faces, right? It's got a base up there, a base down there, and then this, the cylinder part of it, well, I mean, the whole thing is a cylinder, but the actual, like, colored part you see would unfurl if you cut the can, and it would become a rectangle. So it has faces as well. So the surface area is all the area that you can see. Okay, any part of the solid you can see has surface area. So let's talk about a net. A net is not that. Well, okay, it is, but not in math. Okay, in math, when we talk about a net, we're talking about something that's used to represent a 3D solid as a 2D object. Okay, now it's helpful for finding the surface area of a solid. So I'm going to bring down this pizza box. Okay, and this pizza box actually has a net. Now, can we see it? No, we have to draw it. But the net of a pizza box basically means, hey, unfold a pizza box completely and see what you get. So if we did that, we would get something that looked like that. Alright, obviously that is an incredibly rough drawing, so please forgive me, but there's one piece of pepperoni left for you. So make up for it. Alright, anyway, so that's a net. Okay, so if you can tell if you unfold the pizza box, this is exactly what you would get. And this net shows us all the surface area. This square has surface area, this rectangle has surface area, and so on and so forth, okay? Alright, so we're going to use a net to find the surface area of a rectangular prism. Alright, so I took some time to actually draw a proper pizza box out, and I did not do that freehand, I did it with shapes. But anyway, what we're going to do is we're going to say this is the net of a pizza box, right? So it's a pizza box that's been completely unfolded, and these objects here are squares, and they're 16 inches by 16 inches. And that we'll also say every little border here, like that, those are all going to be 2 inches. So those are the only dimensions we're working with right here. Every little thing is 2, all the long pieces are 16. So if we were going to find the surface area of this rectangular prism using its net, what would we do? Well, we have some identical objects, right? I have 2 perfect squares. So I'm going to take, and I say big S for surface area, I'm going to take 2 of the squares, okay? Now, if you look at this pizza box, these big squares are on the top and bottom. Now, in a rectangular prism, it doesn't really matter which one you call it, but I would generally call that the base. So you could also say surface area is 2 times the big B, or the base. Now, we're going to add to that the area of what? Well, the other little rectangles. Now, what did we call those, though? Well, let's think. A surface area is the sum of the area of the solid's faces. So these are all faces, but we identified the big ones as bases, okay? So what would we be left? Well, the surface area of the other faces. Now, how many of those do we have? In this case, we have 1, 2, 3, 4. So I'm going to say 4 of the skinny rectangles, or plus 4, you could say other faces. All right, so let's actually plug in what we know. So we got to find the area of this base here. Well, if it's square and one side is 16, it must mean the other side is 16, right? So the area of that would be 256, and that would be 256. Okay, so we have part of our formula. Surface area is going to equal 2 times 256. Plus, well, it's going to be 4 of the other faces, but what are those other faces? Well, let's see. That's going to be 16, that's going to be 2, so each and every one of those is 16 by 2, okay, otherwise known as 32 inches. So we have 4 pieces that are 32 inches, 32 square inches. So we just now solve it, right? Order of operations, 2 times 56 is going to equal 512. And 4 times 32 will get you 128, okay? And if you add those things up, what do you end up getting? Well, you get surface area to equal 640 inches square or square inches. So there you go. That's how you use a net to find the surface area, in this case of a rectangular prism like a pizza box. And I forgot, let's call this item number 3. And now we're moving on to item number 4. Alright, so item number 4, we're going to talk about lateral faces and lateral area. Okay, so lateral faces are the faces that are not bases. Get it? It rhymes. So lateral faces would look like this. Okay, so if you had a rectangular prism, okay, like that, and we identified the bottom as the base and the top as the base, then we would say that all the other faces are the lateral faces. So if we turn this thing into a net, it would look like this. Okay, and we would say that, hey, these are the bases. So what are the lateral faces? Well, these are the lateral faces. Lateral faces, lateral face, lateral face. So that leads us to the next point. What's the lateral area? Well, it's the sum of the area of the lateral faces. So in a rectangular prism, you would find the area of this whole area right there by taking the length times the width, or the base times the height, however you want to think of it, and you can find the lateral area of that. Alright, so now let's talk about finding the surface area of a prism. Alright, so we have this triangular prism here. That side is 8 centimeters, this is 6 centimeters, and we'll say the hypotenuse is 10, and that length will be 18. Okay, so we're going to find the surface area of that prism. So we're going to use a net to do that. Now, when we make the net, what do you think it's going to look like? Well, let's see. That's what I get there. Okay, so let's identify some parts. Up here, before we even draw the net, you know what? We have to think about, well, what are my bases? Well, is the base always what the, where the ground is, or the bottom of the figure? Well, not really, because remember from the solids video, we learned that a base is going to be parallel to another base, right? So if you take this triangle that's partially outlined in red, partially in black, that I'm going over here with the laser pointer, is that parallel to any other side? No, right? Or it's not congruent to any other side either. So it can't be the base. But take these two triangles, right? They appear to be parallel to each other. They're going to have the same dimensions, so that's 6 and 8. This would also be 6 and 8. Their hypotenuses are 10, so they're the same triangle. So the triangles are actually the bases here. Okay, so we would identify those as the bases and those as the bases. So we're finding the surface area here. Now, how do we do that? Well, we're going to take the area of the bases plus what's it called from the previous example? The lateral area. Okay, and a lateral area is this area that's made up of every other face that is not a base. Okay, so how do we find the area of the bases? Well, let's see, the bases are 6 by 8, and the hypotenuse is 10. Well, let's see, area of a triangle is base times height divided by 2. Okay, so the base would be 8 of these triangles, plus the height is 6, we're dividing that by 2. So that's like saying 48 divided by 2, which is really like saying 24. Okay, so each and every triangle is 24 square inches. So we're going to kind of keep writing our formula, and we have 2 triangles, both which we said have area of 24 square inches. Now, how about the lateral area? Well, when we created the net, what we found was that, we're going to have one kind of length or width there that's 6, one that's 8 that came from there, and then the other one is 10, right, which came from there. Okay, so do we know the area of this lateral area? Well, sort of. I know that this distance there is just 6 plus 8 plus 10, right? So that's 24. And we know the height, because here it's 18, so here it's also 18. So actually the lateral area, which is, I'll do this in blue, is going to be 24 times 18. And 24 times 18 gets you 432. So plus 24 times 18. All right, so we said that was 432. Adding to that, well, let's see, 2 times 24 is 48. So 432 plus 48 ends up getting you 480. Okay, and I believe I said we were talking about centimeters, so centimeters squared, right? Would be our final answer. 480 centimeters squared is the surface area, the area of the bases plus the area of the lateral faces, or otherwise known as the lateral area. All right, so this is a problem that's near and dear to my heart. Why? Because of this guy. Pepsi Blue, best soda I've ever had in my life. They did like a limited run of it back when I was a kid, and now it's gone and you can't find it. I still have an empty can that is like sitting on a shelf, almost like a trophy. So valuable to me because it was just absolutely delicious. And I don't think any of you guys were probably around or at least alive when you could have soda. So I am very sorry for you. But for me it was great, but now it's even more sad because it's gone. So anyway, we're going to find the surface area of a cylinder, which of course a soda can is a cylinder. So if we were to draw out the net of a cylinder, what do you think we'd find? Well, remember, it's just taking a 3D object and representing it as a 2D object. So with a cylinder, what we would do is we would come down here and we would pretend to cut, can't really see that, to cut the cylinder right down the center like that. Okay, right like that. And if you did that, but you didn't cut through the top or cut through the bottom, you'd be left with a rectangle. And of course you'd have two bases left. Now why are those the bases and not this? Because if you look, the top and the bottom are going to be the same. Okay, they're congruent. They're also parallel to each other. Okay, a soda can does not look like that. Okay, where that's the top and that's the bottom. That's not a soda can. All right, this is a soda can. So if we're finding the surface area of a cylinder, we're just going to add the area of the bases to the area of this rectangle, right? So that's easy enough. So surface area of a cylinder would equal area of the bases plus the lateral area. Remember, the lateral area is the area that's made up of everything that's not the base. So that's right here. So let's say we, create the net of the soda can, and it turns out that that distance right there is, we'll say, 2.2 inches. All right, and so what is that distance right there? It was halfway across the circle to the center, so it must be the radius. All right, so let's see. That's the surface area of the bases. Well, we have two bases, so we're going to have 2 times whatever the area of one of the bases is. How do we find the area of a circle, though? Well, A equals pi r squared. So we're really going to change that into pi times 2.2 squared. Okay, so what is 2.2 squared, though? Well, 2.2 times 2.2 gets you 4.84. All right, and then 4.84 times pi, we're going to round our answer here. The area of this circle, one of the circles, is going to be, we'll say 15.2 inches. All right, so I'm going to insert that 15.2 there. All right, now keep in mind that we've got to add to the lateral area, so it's going to be this times this. And let's say the height of the soda can is, let's see, 1, 2, 3, 4. We'll say 5.3 inches. But what's the length of that there? Now this is super, super important. Let's think about how that length would be created if we cut that soda can down the middle. Well, think about this. If you took one of the bases of the soda can, right, and it was cut right there, and you unfurled it, you would get that sort of shape, right? And if you took that length and you curled it back up into a circle, you would get that right there. So here we have a circle with a radius of 2.2, and we have a distance around the circle that if we chopped it right there and unfurled it, laid that part out that way, laid that part out that way, we would get that length right there. So what is the distance around a circle? It's the circumference, right? Circumference is the distance around a circle. So I'm going over here so we have some more room. So how do we find the circumference of the circle? Remember, circumference equals pi times the diameter. But we don't know the diameter, do we? Well, not really, but we know the radius is 2.2. and the diameter is all the way across. So it's 2 radii, right? So C would then equal pi times 2 of the radius. Well, the radius is 2.2. So what's 2 times 2.2? Well, you guessed it. It's 4.4. So pi times 4.4. If the radius is 2.2, then the diameter is 4.4. So what is 4.4 times pi? Well, rounded, that would get you approximately 13.8. Okay, we're talking about inches here. Now, is it inches squared? No. It's just inches, right? We're talking about circumference. It's distance. All right, so what does that mean? Well, it means 13.8 is also equal to this, right there, that distance. So now we can calculate the surface area, the lateral area, be 13.8 times 5.3. So 13.8 times 5.3 gets you 73.14. Now that is inches squared, just like this will be inches squared as well. So let's do this right here. 2 times 15.2 is going to get you 30.4. And we already said we know that's 73.14 right there. And again, that figure came from multiplying that by that. And so 73.14 plus that 30.4 ends up getting you 103.54 inches. And we're talking about surface area, so inches squared. And there you go. The surface area of that Pepsi Blue soda can is 103.54 inches squared. All right, that's all I have for you guys in this video. Thanks for sticking with it. See you in class.